What's happening, everyone? This is Clark Stevens with Biznalysis here with another video on Tableau. And what we're going to do is recreate a Sankey diagram, as you can see on the screen. This is a method that was done by Jeffrey Schaefer with input from Jonathan Drubby, Tableau Zen Master. And Jeffrey runs his Data Plus Science blog. It's great. Highly recommend you check it out. But what we have here is states ordered by their happiness from 2012 to 2013, and each state has a rank, and you can see how it changed. So Hawaii was number 1 in 2012, went down to number 8 in 2013. North Dakota went from 19 to 1. This is about the time where the shale oil boom really hit, and lots of economic activity in North Dakota, so it makes sense. What I want to do is extend this to use custom SQL for data prep, so that everything can be published to the server and then you just forget about it. Everything refreshes automatically. There's no Excel spreadsheets having to be refreshed with the extract. Date filters are dynamic, so just set it and forget it. But before we do that, here is the data powering that visualization. It was included in the blog post. Basically, we have each state and its ranking in 2012, its ranking in 2013, and we have this column called T. Each state is repeated 49 times. There's 49 rows for Hawaii. The values don't change, but the T column changes. Then Colorado has 49 rows, and T starts at -6 and increments by 0.25 all the way to +6. And this, we'll see later, but this basically gives us the curve, the nice curvature of our line that you see here. But the first step, before we worry about that, is we need one row for each dimension, and then its old ranking and its new ranking. We are not using that same data set, though. We're going to actually use Microsoft AdventureWorks, which is a sample database that ships with Microsoft SQL Server, and it's a retail store database. What we're going to do is rank salespeople. So we're going to see how salespeople did in 2012 versus 2013. So here's the data. It's if you're curious, it's hosted on Amazon Web Services on a SQL Server RDS box. Remember, we're going to look at sales and salespeople. So there's a table called sales order header that contains a lot of the sales data. We have a column for total due. That's what we're going to use to rank the salespeople by. There's a salesperson ID that joins to this person table, which has first and last name for the salespeople. There is some SQL involved. Like I said, we're doing all the data prep in SQL. So if you have, basic to intermediate understanding, you should be fine. I am going to post all of my queries so that you can kind of reverse engineer it and see it in action. So here we go. The first thing I want to do is write a SQL query that gives me all of the sum of orders for all of my salespeople. This business entity ID is just the primary key. It joins to salesperson ID in this case. And then instead of first name and last name, as you can see over here, we're actually going to concatenate them together so we just have one field. Here we are. We have all of our salespeople and the sum of their value of their orders. But remember, we just want 2012 and then 2013. So we can use a where clause. And this is great. Now we've got 2012. There's 14 salespeople with sales in 2012. Problem is, this is hard-coded. So let's say we wanted to look back 1 year. If we put, let's say we were running this in 2013. It's actually 2016. And we said look back 1 year. Then when it ticks over to 2014, we'd have to go in and modify the SQL query again by changing this date filter. We don't want to do that. We want this to be set it and forget it. So we're going to do a dynamic date filter. And I'll show you what I mean. All right, so it's 2016 at the time I'm writing this, and this query is saying, look back 4 years from today and give me the year of that. So it's 2012. When this turns over, it's 2016 right now, when it goes to 2017, this answer will give 2013 instead of 2012. So it's totally dynamic. We can just replace that hard-coded 2012 with this statement. Run it, and we get the exact same results. It's just this is dynamic. The next thing that we need to do is rank the salespeople. So we're going to use a window function to do this. This gets a little hairy, but again, I'm going to post this online, so if you don't get it, that's fine. We've got our rank. So Jillian was ranked number 1 in 2012 with 4.8 million in sales. Jay was ranked 4, and Amy was the last. Now we can get our new rank, which is going to be the year 2013. We're just going to copy that whole query and change 2 things. We're going to tell it to look back 3 years, and we're going to call our ranking function new rank instead of old rank. And now we run this, and we see the same data, but for 2013. There's actually 17 salespeople that had data in 2013. There are a couple more things that we need to do. We need to stitch this together, and we want this to be custom SQL that can run in Tableau, so it has to be one query. So we're going to turn these both into subqueries. Calling the first one O for old, second one N for new. Basically, when you wrap a query in parentheses, SQL will treat that just like a table. So now we've got 14 rows because there was 14 salespeople that exist in both of these. And that is one limitation of this. You're only going to see people that had sales in both years. There's definitely ways to handle that. It's outside the scope of this, but just for this purposes, you're going to see people that had sales in 2012 and 2013. Or better yet, since this is dynamic, 4 years ago and 3 years ago. But Jillian was rank 1 in 2012, went to rank 4 in 2013. Awesome. There's couple issues though, because there are salespeople that we want to only have salespeople that existed in both years. Just in the interest of time, we have another subquery that we're going to use as a filter. So basically, within each of these queries, we're going to put another query that just selects all the salespeople that had sales in the other period. So here we're looking back 4 years. We want to make sure that we're only seeing people that had sales 3 years ago. We'll do the same thing here. Everything works. Okay, so this is our SQL. That's step 1. Get it so you have all your salespeople and the old rank and the new rank. Step 2, let's go back to this Excel. We need this T value here, all right? And we need it to repeat for each person. Now we can handle this in SQL, but we're going to use Excel to generate the SQL. And I'll show you, and I'm going to post this document as well. But we know that the T, just in this case, goes from -6, and it goes down by 0.25. And if you want more information on why this works or how this works, go to the Data Plus Science blog. It's spelled out nicely there. We're going to use here Excel's pattern recognition to go get all of our data. So now we've got -6 all the way to +6. Now let's build some SQL. Can you concatenate the string select with this? Now select -6 as T. I can just drag that down, and now we've got all this SQL. You can copy and paste it back into our SQL server. So this is on a virtual box, I don't have copy and paste set up yet. Kind of new to it, but here it is. Exact same thing that I just showed you. So let's just run it by itself so you can see what this does. It's just selecting the string. So we've got a column T with all of this. It's not the most performant. You would probably want to actually materialize this into a table if you're going to run this on a production dashboard, but it works for our purposes since we're not dealing with a ton of data. So what we're going to do is we're actually going to do a cross join or a Cartesian join, which is going to join every record with this string and kind of blow it up. Now what we want is every salesperson to be repeated 49 times. We know there's 14 results to this query. So what we're expecting to see is 14 times 49 is 686 results. Let's see if that's what we get. 686. So Linda is repeated 49 times. Jay is repeated 49 times. So we're good to go. This is our SQL. This is our data source. It's completely dynamic. As the years tick over, this will change. The T's there, set it and forget it. So that's step 3. Step 4 is to actually build the viz. So here it is from scratch, and we're just going to follow the steps put forward in the blog. So the first thing we have to do is make some calculated fields. Again, for details on how this works, go to the Data Plus Science blog entry. This is the function to give us our curve. Create the asymptotes. This takes the sigmoid function and relates it to our ranks. This makes the size of the bar bigger based on the change from old to new. And then there's a color one, which I'm going to copy because it's got a decent amount of text into it. It's basically got hard-coded quintiles. So first quintile, second, third, fourth. The next step would be to make these quintiles dynamic. So if more salespeople come in, this changes. But I can't do all the work for you, so we're not going to handle that here. Now let's just go ahead and build it. And here's where you can see how T works. There are 14 lines here, one for each salesperson, and there's one dot for each T. I'm going to make enough room for my labels. Change the default format of curve to not have decimals. We'll format the labels. Make sure that it labels both ends. Color on color. Size on size. So now the bigger moves have wider lines. Let's change our color. All right, and here's our graph. Now we can throw it on a dashboard, put the year labels, and make the colors just like he's done. But this is it. Thanks a lot for watching.